Okay, so we're gonna continue with another example. On this case, we're gonna do linear differential equation. I apologize for the sound. It's hard for me to figure out what is happening. Sometimes this sound is off. I'll try to figure out what is wrong. I tried to eliminate the noise. It looks like the computer was getting hot, so it's like the fan was making some noise. Okay, so for linear differential equation, we're gonna solve this example. This is x squared dy dx plus x times x plus 2 y equals e to the x. Okay. So the first step for solving a linear differential equation, so of course it's to verify that this is linear, but of course you can tell that this is linear because it has y prime, y, and f to the x. This one is f to the x. I think when I push these colors, I will check my theory. When I push these colors, the noise, the sound gets affected. So we'll see. So the first step is rewrite the equation in the standard form. Let's call it standard form. In the standard form. And this is dy dx plus px of y equals f of x. Okay. So to do that, so we need to divide by x squared, right? So we do dy dx plus x plus 2 divided by x squared, y equals e to the x over x squared. So try to don't go too fast here because a lot of mistakes happen, okay? So here we can cancel, if you want, we can cancel the x with this x squared, right? So we can go, let's cancel this x and we can do this. Okay, that's what we have. So the next step is multiply both sides of the equation times the integrating factor. Times the integrating factor. And what's the integrating factor? Integrating factor is mu of x that is equal to the e to the integral of p of x dx. Okay, that's your integrating factor. So in this case, we have e to the integral of x plus 2 over x. So it's easier for me to write it like x over x1 plus 2 over x dx, so I can integrate, right? So this is my p of x. This is my p of x, right? This is my p of x. So when I integrate this, what do I get? I get mu of x equals e to the x times, plus 2 ln of absolute value of x, right? But then we don't like those long terms, so we can do e to the x times e to the 2 ln of absolute value of x. But look at this nice property, right? So this can become e to the x times e to the ln of x squared. And I can eliminate the absolute value where you want to put the absolute value. And you can eliminate it because this is the square. So the absolute value square is just let me with the x squared. Now this nicely cancels, so my final answer is mu of x equals e to the x times x squared. And that's my integrating factor. Okay? So what I have to do, so multiply both sides of the equation times the integrating factor. So that's what I'm gonna do. So e to the x, x squared times dy dx. So I have to go no, sorry. E to the x times x squared dy dx plus e to the x times x squared times x plus 2 divided by x y, and then e to the x over x squared times e to the x times x squared. Advice: don't skip steps here, okay? So don't try to do in your head because it will play you games. Okay, you do tiny mistakes and that will affect your solution. So of course we have to cancel, simplify. So let me talk closer to the microphone. So we cancel this with this one, cancel one with that one here. So let's write our equation. So let's not be lazy. So dy dx plus e to the x times x plus 2 y equals e to the 2x, right? Is that right? Let's check our work. E to the x squared divided dx, e to the x, this cancel with that one. We get x, and then x plus 2 y e to the 2x. Okay, so that's my last part of the step number 2. Part 3. So the part 3, the step 3, this is kind of the most interesting part. So I'm gonna read it like this. So rewrite the ladder equation. Rewrite the last equation, or the equation obtained at the step 2. On step 2, as rewrite it as derivative with respect to x of the integrating factor, that's mu of x times y, okay, and equals to mu of x times whatever function you have at the beginning, f of x, right? But so for me, it means I can rewrite the whole equation, all this part can be rewritten as derivative with respect to x of the integrating factor, that is e to the x times x squared. E to the x times x squared times y, right? And this is on the left side, we have e to the 2x, okay? So that's the nice part. So this make any sense? So let's check it out. So this, of course, this is fine because I'm just, this stays the same. Well, I'm making the change on the left. So let's check it out. So for this part, the derivative with respect to x of this is a product. So maybe we can do the product like this. So it says that is the derivative of the first equation times y without derivative. So what is the derivative of the first equation? The derivative of the first equation is e to the x times x squared times y. So, oh, we need to expand this, okay? To verify this, we need to expand it. So we get e to the x and then x squared plus e to the x times 2x, right? And all these times y and times y. You expand that. So when I do this, the first derivative will be e to the x times x squared times y. So that will be this part. And the plus the derivative of the next one is e to the x times 2xy. E to the x times 2xy. So that's my second part. But it was a product, okay? So now I had to do e to the x squared times y prime. That's it. So I do it fast because I want you to double check. So this is indeed, these two things are fine. They are the same, okay? So I can keep going. So now that on this step, I rewrite it, right? I had to integrate both sides of the equation and solve by y. So I'm gonna, first step, integrate both sides of the equation and solve by y. Okay, so that's what I'm gonna do. So I integrate both sides. I have lots of questions here. So by fundamental theorem of calculus, these things cancel, right? Because the derivative and the integral cancel each other. So this is e to the x times x squared times y. And what is the antiderivative of this? This is e to the 2x divided by 2 plus c. Okay. So my final answer, I need to now solve by y. So I just can write it like this. E to the 2x divided by 2 plus c, all divided by e to the x times x squared. Okay, so and now you want to write in another form, you can write it like e to the 2x divided by 2 e to the x times x squared plus c over e to the x times x squared. So you want to even write it in another way, in a more simplified way. You cancel these two, so e to the x over 2x squared plus, so let's write it like this, so people is exact. So I review some college algebra stuff, okay, because some of you have been saying that you don't remember a lot of these laws, so I'm just, let's put it like that. Okay, so that's my final answer, and you can verify it. I'm not gonna do that, but you know how to do that, right? So you'll have to find dy dx and multiply times square, and then multiply times y times all this x times x plus 2, add all the things together, and the answer will have to give you e to the x. Okay, so with that we can finish.